Hi, good evening, everyone. Can you open your camera? Yeah. Uh, okay, the agenda for today. Yeah, welcome to Plan 258. Okay, so today I would like to remind again that tomorrow we have midterm exam. Okay, from tomorrow until 26. Okay, so that is Friday, from Saturday to Friday. So from 6 a.m. until Friday 4 p.m. Okay. And then our class today, the agenda is supposed to talk about this. Can you see? So, yeah. So some of you get excellence in BEP assignment last meeting, so you can present. Okay. And then last week also, we did not finish our project presentation, right? So I hope you can present it today, okay? And then we will discuss the remaining BEP and capital analysis. And then if time permit, we can continue with outlier detection. The slide is already inside Moodle. Okay, so is that okay? So please prepare. Okay, so for the BP assignment, anyone want to present?
Hi, sir.
Okay,
I'll
go.
just share my screen, sir.
Yeah, it's okay. Make co-host. Okay. Go ahead. Yeah.
So should I just proceed with the main part, sir?
Okay.
Okay, sir. Since we already done the scenario 1, 2, 3 previously in our lecture, I'll just proceed with the main part of the homework.
Okay. Ah, not this one. The new
This
one.
one, sir.
Oh,
The large. Which assignment, sir, should I present?
the last one. This week assignment.
The
This is
small
last week.
trader, sir. Okay, sir.
Right. Right. Okay. This one.
Here, sir. So, for the previous assignment, sir, we were asked to determine what price will the two in what do you call this let's say investor or business owners would need so that it would be competitive since in the mindset of people the smaller price will be uh they will favor the person with the small or the company with the smaller price. We need to determine the minimum price of the business owners. So the given for Susie, we have $10,000 as the capital. Then fixed cost of 25 this is only for Susie.
Okay.
2,500. Then let's just say the backlog. She will receive the um payments, delayed payments at 3 months, which is the which we will call T. Then for Larry, we have $10,000 as his capital for the C. Fixed cost for Larry is 10,000 or the overhead, which we can also call the fixed cost. Then they have the same backlog delay or time to receivable of 3 months.
Mhm.
Then as per the problem, they are getting their materials from a common supplier and
Mm.
a variable cost of $1 per item. Both of them, Susie and Larry. So we cannot proceed yet directly to the minimum price of their product. I mean, the minimum price that we will sell their product. So we will first get the N star or the BEP number of items to sell for it to be at BEP break even. So what we formula is 1 over the unit variable cost, which is $1. I will just get first for Susie times the C2, this is capital cost my over the times receivable C5 minus its her fixed cost. Then if we can, I also put a note. I will get the exact value here is 833.333, but for us to be safe, I just rounded off to the nearest whole number since for commonly the number of items in the industry cannot be sold as fraction
Okay.
except when we are giving kilo or grams like that. But commonly it's one whole unit. So I just rounded off. So it will be a whole number, not one item, and it will rounded up. So it will be not less than the computed BEP. So I will get the value of 834. Then I will proceed with gross margin. I will get the gross margin. By formula, it's fixed cost times the amount delay or the months receivable, time of receivable, which is T. So F times T divided by capital. So I will get, and I will just multiply by 100 so I can get a percentage. The actual value is 0.75, but I just gave this unit of percent. So I got 75%. Then I will proceed with the um then I can go now and compute for the minimum price. So the minimum price is the unit variable cost or variable cost per unit of the item, which is in here in my Excel it's C3 divided by 1 minus the gross margin in decimal. So 1 minus 0.75. Again, I rounded this up to the nearest to the nearest two decimal since we're talking about money. Commonly, we are computing money into decimal places only. So I will get roughly a value of $4. Then the last needed to compute is the revenue at minimum price. So to get the revenue, we will just multiply the minimum price times the BEP or the N star number of items. I will get 3,336 for Susie. Then for Larry, I will just repeat my steps which I use for Susie. First, we will need to get the N star again. So same process as Susie, 1 over the variable cost times the quantity of capital over times to receivable minus the fixed cost. Then again rounded up to the nearest whole number. So I got a value of 23,334 items to be sold so I can be on break even. Okay, then next step I will get the gross margin. Same steps, fixed cost um times to receivable and
Okay.
then divided by the capital. So I will get a value of 0.3, then I will just multiply by 100, so it's 30%. Then next, I can now compute for the minimum price for Larry.
Okay. So, the one that invariant here is not the unit variable cost. Try to divide revenue divided by capital.
Revenue. Both, sir.
Both
I will try first.
divided by the capital. Okay, that one is the same as 1/T.
Oh, yes, sir.
Yeah. So these are the invariant.
Okay, sir. So it's the backlog, sir, that is invariant.
Right. Okay. So very good. Yeah.
So here's the summary, sir, the orange one.
So what can you conclude? If you are a small trader, comparing to the big trader, does the capital actually matters or not?
Sir, the for the small trader, the it matters, sir, because it you need to sell your products at a higher price for you to just to be break
Exactly.
even. Unlike
Exactly.
when compared to Larry, he can sell at a minimum of $1 compared to $4.
See,
But the ano lang,
but the
the
number of items they need to
yes, sir.
sell is
So
very big, right?
I can also maybe, sir, I can conclude that if Susie and Larry are only the two company in the world, I can just increase my price up to 3.99 or something like that, at least lower than Susie, but I will
Much higher, yeah.
yes, sir, I will get less number of items to sell, but I can get a big profit. Unlike Susie, she needs $4
Yep.
just to break even.
So this is what actually the system in the economic work, isn't it? Right.
Yes, sir.
That's why you have distributor. That's why you have small trader. Okay, because the capital matters. Okay, that's why the smaller trader, okay, they cannot survive if they make it very small price.
Yes,
Okay?
sir.
They need to mark up in order to
Break
survive.
even. Yes, at least break even.
Yeah. So at least this model is very useful, no? So to explain certain things like this. Yeah. Okay, thank you, Joven. Yeah.
Thank you, sir.
So those who did not make the assignment yet, so uh, please make your assignment, okay, before the midterm, so that when I submitted the grade after the midterm, so you can also have, so everything will be all right. Okay. Okay. So for the project presentation, are you ready? You want to
Just
present?
hello, sir. Can we go first, our
Okay,
group?
go.
Okay. Just wait.
Give it on the co-host.
Hello.
Yeah,
Can you see my screen now?
yeah, I can see.
Okay. Compressed. Just to have a bit of a background regarding our project or the selected project that our group uh decided to um focus in is the Barangay Mantivo, Cebu, Zamboanga del Norte to Barangay Vitali, Zamboanga City Diversion Road. But we decided that the base case will be only the road project without the community shuttle system. And then It is a comprehensive project encompassing the construction of a 32.46 kilometer concrete road, including two bridges linking these two barangay, the Mantivo and Vitali. And this initiative is complemented by the integration, supposedly, with a community shuttle system inside this area, since there are a lot of isolated communities, and there are a lot of planned or um, future project of schools inside this area. And then, recognizing the need for an inclusive transportation approach, the project incorporates a community shuttle system. The road infrastructure will not only connect distant areas but also ensure seamless transportation within the communities. So we have um, our objectives, again, like what we have presented before: road connectivity, community shuttle system, economic and social development as well. And the benefits: holistic connectivity, local mobility solutions, and economic synergy. So the evaluation criteria: first, we get the divertible traffic and economic evaluation. So we just switched this one. We forgot to replace it. It should be, the base scenario should be the diversion road only, and then the alternate scenario will be the diversion road with community shuttle system. So this is what it looks like with its traffic survey stations. When you check it on the road inventory online via the DPWH website. So I just identified it like this: A, B, C, D, E, F, G, H, I, and then get it, and then use this data for traffic tracing and getting the AADT for each. So the first, I'll just go to my Excel. So this is a program actually I created using and actually tracing the traffic between those stations. So this is the 2022, it is based on the 2022 annual average daily traffic. This is the latest data that we have in DPWH. And then getting all the this one again, the traffic stations. And then I'll just have to input everything or all of the assigned stations. So we have A to I, and then it will actually, it's already automatic. You just, when I put something here, like this one, for example, it will return. But when it will actually, oh, there you go. It will get the data here already. Whatever stations or survey site ID you put here until to what letter you have to use or utilize. And then it will also get automatically depending on the um, s- on the case, since it is just going here to here. Since the project is going here to here, so we decided that we use this traffic data. So any any vehicle moving from this point to this point until this station, so it will capture here the divertible traffic that will possibly use uh the project road. So we got a divertible traffic of 16% for passenger car. We actually, I always put zero for PU PUJ when getting the final divertible. So then 5.34% for goods utility, 2% for trucks, And I think that's supposedly that will be utilized for the next Excel file that we have. This one is actually the file or the program that I'm using also in the office, but I can't, um due to private data privacy, I can actually share it. So just using the normal traffic that I get from my first Excel here, using the normal traffic data here, I just input it here for the traffic projection, and then also the divertible traffic. So it will automatically, based on the engineering inputs as well, it will consider different factors such as lanes, number of lanes, the section length of the without the project, and the with the bypass or with the diversion road, since it's a 32.46 kilometer. And then without the project, you have to actually move from from here to here for at least 60 kilometers, I guess. 64 kilometers is the without the project. You have to travel at least 64 kilometers without the project road. So if the project road is built, you only have to traverse at least 32.46 kilometers. So, and then the number of, I mean, the details that we have put for is also here. And also the maintenance cost. And then we have a traffic growth rate. This is the traffic growth rate that we are using also. And then for the bypass, I just get the benefit only, the running cost savings, and also the time cost savings here. And then we have a assuming assumption of 10% generated traffic benefits from building the road project. So you will have this. I just put the running cost savings we got from that program, and also the time cost savings, and then the maintenance cost is given also here. You can see that there is a maintenance cost here. And then where is it? These are the assumptions that we use. The construction year will be 4 years. So the construction cost will run from assuming that the road project will be constructed by 2025, or will be started by 2025 and will be finished at 2028, and the opening year will be at 2029. So, and then the economic cost is assumed to be 95% of the construction cost. So from here, you can see that there is a 95%, 0.95 factor here, just to reflect the economic cost, assuming that um, your economic cost is 90% of the construction cost. Then the construction cost, this is the construction cost based on the profile of the project. The running costs and time costs were computed using the program by DPWH, which I presented earlier. And then the opening year is 2029. And the benefit stream period is usually assumed at 20 years for road project. For bridge project, it is assumed at 30 years. 30 years stream period. And then the social discount rate we use is 10%. So getting all the total savings versus the total cost, you have the net benefits, getting the NPV and EIRR for the road project only. You will have already a 22.61% EIRR, which is greater than the social discount rate of 10%, and then a 3.47 BCR or benefit cost ratio, indicating that um, the project is also is a good indicator that the project is implementable or viable, and also a positive NPV. So from the sensitivity analysis, you can also see that what I use here is, what if there will be a 20% additional 20% of the total cost? What will happen to the project's viability? And the next case is, this is the first case, I mean, this. And then the next case will be, what if the benefit will be deducted 20%? So this one is plus 20% in cost, then benefits unchanged. This one, the cost is unchanged, but the benefit will be deducted 20%. And then the last scenario will be there will be an additional cost of 20% and also a deduction of 20% for the benefits. So this is I think this is the worst case scenario. So from the worst case scenario, you can still see that the project is still viable since the ERR is greater than the social discount rate used in the evaluation. Where is it? There you go. I think that's the end of our presentation.
Okay, so is there any question from other groups? Okay, I think it's excellent. Yeah. I have no comments, so you just finish it and make a report and
Okay, sir.
yeah, I think it's excellent. Okay. So
Thank you,
any
sir.
other, yeah, thank you. Any other groups want to present? Yeah, Junati.
No, sir, our group will be presenting our progress report.
Mhm.
Let me just share my screen. Wait. Wait, sir.
Yeah, so for Resi a while ago, so probably just the strategy, okay, to implement that project.
Yes, sir.
Okay, so
Sir, I just have one more question, sir. Do you have any alternative strategies also in getting the divertible traffic? Sorry, Junavi. Sorry.
not right now. Okay, so probably I need to absorb what you are doing more detail to be able to get that answer.
Okay, sir. Thank
Okay,
you.
yeah, thank you. Jonathan, please.
So let me just present the updates or the progress for our group paper or group project, which is optimizing transportation for locals and travelers for the province of Guimaras. So just a little bit of background. No? Guimaras is actually considered still a small island. And if we look into the review of related literature with regards to small island transportation, the transportation is very vital when it comes to economic, social, and territorial development. And because it's vital, in, for the territorial development, there is also an interdependence among the inland and coastal areas. So for those areas that are located within the island, at the same time, those areas that are along the coast. So transportation, a good transportation system or availability of our choices for transportation is vital when it comes to the development in the area. However, if we look into it, there are still issues being encountered by small island with regards to their transportation system. One is the accessibility issues. Not all small islands are very accessible from the main island or from other islands. So for example, in the province of Guimaras, when it comes to um, going from Iloilo City or the Panay Island going to the province of Guimaras, extreme weather, like for example, typhoon or storm surge, can affect their accessibility and also puts them to uh, being isolated from the services, from the different services they can access in Iloilo City. Limited market opportunities, since it's a small island, there's a limited available market in the area, and as a result, there's a high cost of the products or the services provided in these areas. As mentioned, environmental factors can always affect the accessibility to this small island. So in Guimaras, there are actually various ports but the main port that they use for access from other islands or from other islands here in Western Visayas is the Hordan Wharf, Hordan Wharf and the Hordan Roro Port. Previously, they have the port in Buena Vista, but due to the implementation of the new law on the routing plan or the modernization of transportation in the Philippines, the area was closed since not all of the another factor was also the accident that happened in 2019, and the marina policy on the modernization of boats, transportation boats in the Philippines, wherein that made wooden hull boats are not now allowed to be used as a transportation for passenger transportation. So now only Hordan Wharf and Roro Port are used for access from Iloilo City or from the Panay Island. While in Negros Occidental, the island can be accessed through the Sibasti Port in Sibunag, which is which is 2 to 3 hours away from Hordan, which is the capital of province of Guimaras. So these are the available ports in the province. Currently, they don't have transport system connecting all the municipalities. There are 5 municipalities in the area, but they are connected by land transport or through land transportation. So motorcycle, tricycle, van rental, and jeepneys are available for transportation. So currently, this is the list of this is the proposed routes for the new Modernization Act. This is the proposed routes for Guimaras. However, this is still not yet to be implemented by the province. So as a requirement, currently they have 20, for example, from Buena Vista to Hordan. Currently, they have only 20, and by 2021 to 2024, the requirement is around 23. In this area, if this routes will be needed or will be implemented, when you go to San Lorenzo, through the San Lorenzo Buena Vista route, you need at least 6 jeepneys for 2021 to 24. 2024, San Lorenzo Hordan route, it's 9. Sibario San Miguel, 21. As you can see on the screen, these are the requirements for the new transportation route of Guimaras. However, transportation route of Guimaras. From the previous presentation, Guimaras, as we explained, Guimaras is actually one of the most visited islands here in Western Visayas, mostly local tourists. So if we look into the on the chart on your screen, in 2019, this is the record or of the tourists, they visitors in Guimaras. So most of the visitors here in tourists in Guimaras are day visitors. So they only stay for a day. Some of them stay for a night, but most of the tourists in the province are day visitors. They don't have the 2020 record to 2022 because of the pandemic, so only until 2019. So this is by disaggregated by municipality. So if you can see, the topmost visited island is visited area in 2018 is actually in Nueva Valencia, which is 103 visitors. Nueva Valencia is 1 hour away, at least 1 hour away by tricycle from Jordan. And it is one of the most visited area since that area is where the most of the tourist site are located. So by population, 15 years old and over, the working population in Guimaras, as of 2015, this is a 2015 data. The total population is 174,613, but we do have now the 2021 data, but this according to their PDPFP, this is the available number of population. So issues encountered by the transportation system in Guimaras is one, those areas with fixed routes is unreliable. The transportation there is unreliable since it does not follow a schedule. So if you go to Guimaras and ride their jeepney, some of them stay for example, they have already a agreement that they only stay for an hour. But since not all visitors or not all of the residents in Guimaras use the jeepneys will stay longer than the amount of time they are required or they have agreed. So for example, one jeepney will stay, instead of 1 hour, they will stay more than 2 hours or 3 hours. And transportation services is infrequent. For example, tricycles, for example, jeepneys. In some areas, there are only limited jeepneys. So in Sibunag or San Lorenzo, they only have one jeepney that is currently, one or two jeepney that is currently being used for service. And some are, most of the transportation used by the residents are tricycles, hired tricycles, and motorcycles, or what we call habal-habal. Currently, they only have one transportation terminal and is still under development. So Buena Vista is they only have the transportation terminal or a proper terminal in Jordan, in Guimaras. They do have a terminal in Jordan, but there's no physical facility for it. So they just line up the the services only line up, but no available facilities for the transport for the for these vehicles. So what we want in this paper, what we aim is to maximize the overall transportation efficiency and accessibility for both local population and foreign travelers or local travelers, since this is one of the main issue encountered, main issue that we were able to identify while reviewing their PDPFP and other documents available shared by the province. So just to explain the optimization model, let me turn over the virtual floor to my groupmate, Ma'am Marian.
Hello po, good evening everyone. So I will be discussing the optimization model. First on the upper left table are the particulars or the expenses. So first is the vehicle acquisition, and this is the amount per unit. So for the bus, it costs 3 million per bus, while ferry costs 10 million per unit. Next is for the permits and licenses, it costs 500,000 and 1 million respectively. Next is the operational expenses, which is per unit per year. For the bus, 2.4 million while ferry is 6 million. For the staff salaries, this is the annual salaries for the bus is total of 648,000, while for the ferry is 1.32 million. And lastly, for the miscellaneous costs, it costs 500,000 and it's both 500,000. So the capacity of bus per bus is 50, while ferry can accommodate 150 passengers. So the budget for transportation in Guimaras is 35.124 million. Then we consider the working age group, which is about 102,000. So for the computation of the variable costs and the number of units that can be availed using the allotted budget for transportation. First, for the total variable costs, for the bus, so we just get the difference between the total budget and the fixed cost. So the particulars with single asterisk on the upper left are the fixed cost. So that which pertains to the permits and miscellaneous cost. So the sum of that is the total fixed cost. So we just get the difference. So same computation with the ferry. So the next one is how many units can be availed can be availed using the allotted budget. So for letter N, the formula is the total unit cost over variable costs. So the for the unit cost, we're pertaining to the particulars above with double asterisk. So the vehicle acquisition, operation expenses, plus the staff salaries. So those are the total, the sum of that is the unit costs. So for the bus, we came up with 5.66. So rounded down. So the total number of units that can be billed for the budget is five buses. While for ferry, doing the same computation, Guimaras can only avail one ferry. But if we're going to compute it, combination of bus and ferry, Guimaras can avail 2 buses and 1 ferry. So for the next row, we computed the passengers that can be supported. If Guimaras, we're going to focus to avail bus only. So capacity times the number of units. So 50 times 5, 250 passengers that can be supported. While ferry can only support 150 passengers. But if combination of both, it can accommodate 250 passengers. So if we are going to compute the remaining budget, for example, if Guimaras will going to avail 5 buses, so the remaining budget from the total budget is 3.98 million. While for ferry, the remaining budget is 16.4 million. But if they were going to avail both bus and ferry, the remaining budget will be 3.308 million. So after this, we computed for the sensitivity analysis, which will be discussed by Ma'am Junavi. Thank you.
So for the sensitivity analysis, we for the bus we were, if we look at the graph, based on the results for the sensitivity analysis, the demand will be affected when the price or the price for the bus increase. So since the graph is going to the right part of the graph, at the same one as well with the sorry This one is the sensitivity graph. While for the ferry boat, the same, but comparing with the ferry and the bus, the slope is more defined in the bus, for the bus choice or option. So, sir, this is our progress report for our group.
All right. Is there any comment or question to this group from the other? I have several questions and probably comments. Probably you should change the name. Right? This is semantic, but I think it misleading if we said it is optimization, but actually it's just BEP analysis, right? So just rename it as BEP analysis rather than optimization. Okay. Because in any optimization, you're supposed to have an objective function and then what is the constraint, right? So you did not mention that. So this is the, I understand this is semantic, but otherwise people may think this is misleading. So, second, about the pricing, how you did not tell the price for the passenger and the ferry, and then how about the revenue that they get from here, which you did not include, and then the sensitivity analysis is supposed to be based on the price, right? But you did not include also, so this a little bit confusing. How do you get the demand? Okay, so thank you. If you can explain this today is fine. If not, maybe next presentation. Also, there are certain numbers that is actually off because you are talking about millions of tourists. Is that per year?
For the tourists, sir, it's per year.
Okay.
Sir, the computation is per year
Okay.
based on the data.
So probably we need to convert it to the same unit of per day or per year. Okay. I don't know. So you choose one unit so that we have common unit, right? So if the number of tourists is 2 million per year, is that really enough to have only 20 jeepneys? I mean,
Based on
one jeepney is only 20 passengers. So how accommodate millions?
so for the for the province of Guimaras, sir, usually what they do for if you're a traveler in Guimaras, most of the tourists, if they have a car, private car,
Okay.
they bring it. They also hire, like for example, a van which can accommodate 10 to 13 people. But van is quite expensive, so the rate is actually 7,000 to 10,000 per unit.
Okay.
For motorcycle, usually the motorcycle is only available within from the Hordan area, the city center or the provincial center, going to other, for example, Sibunag or San Lorenzo, but it's not available in the port. What is available is only the tricycle. Tricycle is cost, for example, if you're going to Nueva Valencia, it costs 300 pesos if you hire it, but it can only accommodate 6 people. Oh no, 5 people.
Okay.
Jeepneys usually, sir, are only, tourists don't usually use jeepney unless they hire it for a bigger group.
Okay. So in this case, there is no connection between the PUV that you propose and the tourists, or is there any connection?
For the proposed choice, sir, for the bus and um ferry, we only use the, I think, the working population for the Guimaras, as at that time that we were doing the analysis, they were not able to provide us with the certain number of tourist arrival. So the number was only provided to us recently, and we were not able to indicate it in our project progress report. So
Okay.
as of now, the computation is only for the working population of the province.
Okay, so I think it's interesting that you can include certain strategy. For example, okay, in this case, you probably want to privatize, okay, for the tourists also, rather than keep all the government budget to buy this ferry and buses. Okay, so this is one option that you can probably check what will happen if we privatize certain part and then certain part is belong to the government to be responsible for this. So, well, I don't know. So you can start to think about what kind of policy or strategy when you have a limited budget, and if you can include the private sector, that's probably one way. Anyway, they are already doing it, right? But the part is in the study you did not mention that you can actually make cooperation with them. Okay, thank you. Yeah.
Copy on this, sir.
Yeah.
Thank you.
So, any other group that want to present? How many groups you have?
Sir, I could share my screen.
Okay, no, go on.
Yes, sir. Hold on, sir. Okay. So, sir, again, our topic is about estimating the demand and financial and economic feasibility of a dedicated shuttle service program for BGC employees. So I'm with James and Neil on this particular project.
Okay.
So, okay. Just a little bit of background about BGC. I think everyone knows about this. So it's as of the 2020 census, it has a population of about 11,912 residents, the barangay Fort Bonifacio. But I would assume that the number will be a lot higher if we consider the number of people that goes to inside the barangay Fort Bonifacio and BGC in the morning for work. It is located 11 kilometers southeast of the capital city of Manila. And some of the modes of transportation available here inside BGC are Bonifacio Transport Corporation, the bus routes or the BGC bus. There are also jeepneys, e-jeepneys, and UV Express. And then the nearest MRT station is MRT3 in Buendia. I think MRT3 Ayala station is also near BGC. And then in the future, there will be railway stations for the Metro Manila subway. And then some transport users use their motorcycle taxis, taxis, grab cars, and private cars. Given that the current travel time in Metro Manila is about 2.7 minutes per kilometer, it's a bit slow. There is a vision before that BGC will become a 15-minute city. However, in reality, commuters wait for about 30 minutes to 1 hour in public transport terminals. This forced some of them to shift to a private mode of transportation. However, the problem there is that shifting to this type of mode of transportation leads to an increase in traffic congestion. So, what we are aiming is to provide some sort of provision for additional and alternative transport modes for commuters. So the main objective of our paper or project is to determine two things. One is the demand for a shuttle service and its financial and economic feasibility. The first one will be on the demand. We would want to identify the characteristics and the significant variables that affects a user's willingness to share a shuttle service. And then finally to determine its financial and economic feasibility of the dedicated shuttle service program. Okay. So some of the scope and limitations of our study. So in terms of scope, as mentioned, the area of study or catchment area will be just the Bonifacio Global City. The survey respondents will include both private and public transport users who work on-site face-to-face at least once a week. And we will include all day, afternoon, and night shift employees in our survey. So, sir, we're going to conduct a survey, an online survey for this particular project. For the
Not yet.
limitations of our, sorry,
The survey is not yet done, or
we
still?
haven't, yeah,
Okay.
we're still developing the survey, sir.
Okay.
Right. So for the limitations of the study, the first one will be we won't be including the legal and institutional analysis for this shuttle service program. So we won't be delving into uh, whether the government or the private sector will operate the shuttle service program, or whether there is it is legal to operate such shuttle service program. I understand that there may be regulatory concerns, especially with LTFRB on this one. So we won't be delving into that type of research, but we will be focusing on demand, financial, and economic stability. Then second limitation will be we won't be in the survey. We won't be including a willingness to pay study. So our the fare rate will be just based on the LTFRB data that we will be getting from for public utility vehicles. I understand this is already publicly available data. And then for the operating and capital expenses of the program, we will be using third-party data. And then for the route selection and scheduling, it will be based only on the peak hour trips in Metro Manila. So morning, afternoon, and evening trips. And then finally, the analysis of the most optimal terminal station will not be included. So what we will be doing, sir, in the survey is we're going to identify potential terminal stations, but we won't be identifying if it's already the most optimal terminal station for the shuttle service program, since that would require a lot of data from the users, especially their addresses and houses. Okay. So here are just some of the few references that we've gathered so far. There's a particular good study for the university. This is a study by I think a SURP student or a professor, Peralta Castro. It's about the demand estimation of dedicated shuttle service program, but in this case, it's for a university. Then there are also studies regarding designing employee shuttle service programs for employees in Makati Central Business District. And there's also demand for park shuttle services, stated preference approach. So the third one, sir, is I think that's a foreign study, but the first two ones are local studies. We're trying to complete the 20 literature review needed. So far, these are the 3 that we've gathered so far. And now, sir, since we haven't done yet the actual survey, I'll be focusing on the methodology and how we're going to analyze the data that we will be collecting later on. Okay. So here is the conceptual framework that we will be using. The first one will be to, of course, review some of the existing literature that's related to this shuttle services. And then after that, we will identify the shuttle service characteristics that we want. So in this particular case, we would be identifying the potential terminals or stops for the shuttle service, the most appropriate time and schedule for the shuttle service, and perhaps the cost for the shuttle service program. So what we're basically doing here is just identifying the characteristics of that shuttle service, which we will be incorporating in the survey later on. And then finally, we will be conducting an online survey to get data. I'll delve into that in the succeeding slides later on. And then for our analysis, we will be doing a binary logistics regression analysis to estimate the demand of the shuttle service program. And then after that, we will be doing a financial and economic analysis based on our lessons, and then a scenario and sensitivity analysis. Perhaps, sir, we could also add here BEP analysis as well. I just didn't put in the PowerPoint presentation. Okay. So for the survey methods, it's going to be stated or revealed preference survey. It will be conducted online. So we will just be using a purposive sampling method because the target responders are those that are working in and living outside of BGC. So with our online questionnaire, we're trying to develop it still, but it's going to be divided into 3 parts. We're going to ask the first one. We're going to ask them about their socioeconomic profile, their existing travel behavior, and their stated preference choice scenarios. No? So for the socioeconomic profiles, these are the questions that we're going to ask the respondents. So we're going to ask about their age, gender, occupation, car ownership, household income level, number of days working on site, their work arrangement, whether it's work from home or full face to face, and whether they are a PWD or a student. And then after getting the socioeconomic profile, we will also be asking them about their existing travel behavior to and from BGC. So this includes questions about their mode choice, their origin and destination, arrival time, departure time, trip time. So for those currently using public transport as a mode of transportation, we will also be asking them what's their current travel costs and the number of transfers that they make for currently in their mode of choice. And then finally, this one, we will be asking them their stated preference choice scenario. So how we imagine it is that in the survey, there is going to be a description of what the shuttle service program would look like. So uh, it would provide data on what the terminals or stops are. And then there's going to be 3 types of questions, scenario 1, 2, 3. And then the answer for each question is just yes or no. So for example, for scenario 1, given that there is a shuttle service program that has a fare of 15 pesos for the first 5 kilometers plus 2.75 per the succeeding kilometers and a maximum waiting time of 20 minutes, are you willing to shift to this shuttle service program given your current travel mode? And then the same questions will be asked for the scenarios 2 and 3. Okay. So all of those data that we will be collecting will be used in our demand estimation. And in our demand estimation, the method that we will be using is the binary logistics regression analysis. So this is, I think, the same method that was used in one of the literature review that we've read. So a binary logistics regression analysis is a regression analysis method used when we're trying to predict a dependent variable with only 2 outcomes. So in this case, the dependent variable will be the yes or no answer to this question. So are you willing to shift to the shuttle service program, or yes or no? So that's the dependent variable. The independent variables will be the factors identified in the socioeconomic profile and the existing travel behavior to and from BGC. So that's how we imagine the regression analysis will be. Okay. And then for the demand estimation, what we will be doing, sir, is that we will dividing the respondents into 2. So group 1 will be non-private cars or motorcycle users, and then group 1 will be non-private cars or motorcycle users, and then group 2 will be private car and motorcycle users. We divide them into these 2 groups because I think we understand that those 2 groups have different, I guess, willingness to shift because of the ownership in private cars and motorcycles. So for each group, we will be developing 3 binary logistics regression model. So the model A will contain all independent variables or all parameters identified in the previous slides. And then model B will be all parameters with significant p-value. And then model C will be parameters chosen by us. And once we've completed our demand estimation, that's when we go to our financial and economic analysis. So we divided for the financial analysis, we divided this into two, the revenue and the expenses part. So for the revenue, so it's demand times price. So the demand will be based on the whatever the results of our surveys are. And then the price will be based on the LTFRB approved rates for public utility vehicles. And then for the expense side, these will all be just desktop research. So we will be looking at the data about vehicle cost acquisition, and the number of units will also be based on the demand. For the operating and maintenance expenditure, we will also be basing this on desktop research. So we might look at the current government salary standardization law. And for the vehicle of O&M cost, we will also be looking at some desktop research or from online. So our financial evaluation will compute for the NPV, IRR, and the benefits cost ratio once we've calculated these data. For the economic analysis, how we imagine it is that we're going to do most of the data here will come also from the desktop research, although these are not yet final. So for economic benefits that we've identified, it will be operating revenues of the shuttle service program, vehicle operating cost savings, travel time savings, safety benefits, pollution reduction benefits, and GHG emission savings. For the economic cost, it will be the capital expenditure and the operating expenditure. So similar to the financial analysis, we will be competing for the NPV, IRR, and the benefits cost ratio. Okay. And then last, sir, will be just a scenario and sensitivity analysis. So I guess our alternative scenario one would be if there is a subsidy by government in our corporate entities, so that would lead to a decrease in price and then an increase in demand. And then an alternative scenario two would be a major railway projects are constructed. So, and then the government allows shuttle service terminals to be located in rail stations. So therefore, the demand for the shuttle service program will increase. And then for the sensitivity analysis, we will just compute on the effects on the economic and financial IRR, a decrease in benefits by 10% and 20%, increase in cost by 10% and 20%, and a combination of both. I think, sir, that's our last slide. Yeah.
Yeah, thank you. So is there any comments or question from other group to this group? Right, so the whole plan is, I think, is pretty okay and feasible. Okay, so I have several comments only. I think you're supposed to include the WTP rather than remove it completely in the questionnaire. Okay. So later, even if because you assume something here, right? Your SP questionnaire a while ago.
Yes, sir. We just assume that the fare for the shuttle service program
Right.
will be based on the LTFRB rates for public
Right.
utility vehicles.
Right. So, but just one additional question does not harm you at all
Yes,
about the WTP, willingness to
okay.
pay and willingness to wait. Okay, so that you can compare later. Okay, so and then I think you need to add the trade-off analysis based on your questionnaire a while ago, the SP. Yeah, this
This
one.
one.
Right? So you need to have a trade-off analysis between the fare and the waiting time, right?
Yes, sir. A
Okay,
trade-off
so
analysis, sir.
yeah, trade-off between I think it's clear from here, right?
Okay.
So the trade-off between the fare and the waiting time. So we need to get how much per time, right? And then also you need to compare between the SP and the RP. Yeah? This is the SP, right? So how about the RP earlier,
Yes,
the
sir.
risk behavior? So I think it's better if you can compare the two of them.
Okay, sir.
especially the cost and the transfer trip times. So I think from there you can get better understanding of this. One question: how are you going to get a sample?
Actually, sir, we haven't discussed that much yet, but I guess that will be based on uh I guess the population, or it might be too much.
Okay, so is it a stratified sampling or a random sampling, or how are you going
We're
to
not
capture the actual possible population that you want to be as your target market, isn't it?
mm,
So I mean,
yes, sir. So I think we're
otherwise,
gonna just
otherwise
gonna
it's
use a
not so useful if
purposive sampling.
you just random everything, right? Because you have
Yes, sir.
certain target
Yeah, we're
market.
gonna do a random.
I think not useful if you are using random, because you
I
have
think,
a
sir, how
certain
we're
target
going to do
market
it in,
already,
right, sir.
right? So is it okay if
We'll,
you specify what is your target market, and then you conduct the online survey to those potentially as your target market rather than random,
got it, sir.
right? Because this is demand survey
Something
anyway. It's
so
not really for public transport per se,
yes, sir.
right?
We'll do
Uh,
that, sir.
right. Otherwise, say if you generate say 1,000 respondent, and then only 10 of them are willing to use, then it's not so useful survey,
Yes,
right? So it's better really target
got it, sir.
for your target market, so to get the real sample. Yeah, thank you. Yeah.
Thank you, sir.
Yeah, thank you, Anand. Is there any other group, or this is all? Okay, so good. Okay, so in that case, let's come back to our lesson about break-even points. Okay. Break-even point. Oh, there it is. Hmm. Can you see my slide? Yeah, this is the answer for the assignment, right? Okay, let's do it. I think the one that we left last meeting was up to here, right? So business can go bankrupt. Okay? So one of the reasons why business bankrupt is because there is not enough capital to cover the uh, or the cash flow, not enough cash flow and capital to cover that transaction, so and the business itself. So in this case, we really need to have a relationship between the capital and the price, and what is the minimum capital for the business, or the minimum cash flow for the business. Okay, so yeah. So this is the one of the most reason is based on the lack of cash flow. And the reason of lack of cash flow happen, okay, because of delay payment. Okay, one of the reason is actually because of delay payment, and delay payment, okay, is actually also very common in business. Yeah, from the time you buy the materials until the time you actually sell, okay, you have certain delay, right? So, and certain trusted client may demand delay in payment if they buy in bulk. So, and this is one example. So if you are selling an item for $1, okay, and cost you say 19 cents to produce or to buy, and we have what is it, 5,000 per month to cover your overhead. So this is the fixed cost. So we have the price and we have the unit variable cost, okay, and we have the delay payment of 3 months. Okay. Then how much are we going to need the cash to be just break even? Okay, so in this case, we put what is given. So this is the given is variable cost per unit, okay, 0.9, and then the price and the fixed cost and the time. Okay, and how are we going to calculate this? Okay, so we just use BEP formula. So this is the BEP formula, which is N equal F divided by P minus P. Okay, so you have like 50,000 items per month. That means you need to be able to sell this number of items, okay, just to be BEP, just to be break even. Okay, and that because the price is $1, that means you need 50,000 US dollar per month. Okay, so now for the first 3 months, okay, the fixed cost is about 5,000 times 3 months. That means 15,000. Okay, when you calculate the variable cost, it is 0.9 times the number of units, which is 50,000 items per month. You need 3 months, so in this case, you multiply by 3. Okay, and then the total cost needed for the first payment before this is about 150,000. Okay, so in that case, the first payment that the cash that you need is the 150,000 minus the 50,000 earning. Okay, so that means you after the first payment you actually need around 100,000 in cash. Okay, so look at this. Okay, if we put it here in the Excel. Okay, this is interesting. Why? Because if you look at only the fixed cost, it is only 5,000. Okay, and then the price per unit is $1. Okay, it's like not that big. Okay, so it's small only. So if you think, oh, 5,000 times 3 months is only 15,000, right? Okay, so that is not that big. But the cash that you need, okay, the first payment before the cash flow that you need is actually 150,000, which is how much? Like 10 times, no? 10 times bigger than the fixed cost times the 3 months. Okay, so this is the one that surprisingly make the business bankrupt, right? So you need at least if you, of course, this is happened because the gross margin is very small. Okay, so it's like 10% only, right? So, but at the same time, okay, 10% gross margin here. So you can start to see, okay, the connection between the capital that you need, okay, and the BEP. Okay, and then from here we start to think, oh, in that case, can we model this? Okay, we see here there are some months. That means there is a time. Okay, and okay, the fixed cost is fixed, and the variable cost we can put certain things here, and but there is an accumulation of the total cost. Right? In that case, can we make it into a model? Okay, this is what I continue with this. Yeah? So this is the model that eventually I derive. Okay? So yeah, the model assumption is just simple dynamical system, okay, based on BEP that we know. Okay, we want to know, okay, how much the capital is needed in order to survive a delay payment. Okay, so in that case, we set the T as the number of months of delay payment. Okay, that is the same as the time of delivery of the first sales, and okay, from the delivery of the first sales until we receive the payment. Yeah. So this is the assumption. Now every month we buy the product and deliver it to customers. Okay. So in that case, the total cost is constant. Again, I understand this is probably not realistic, but this is just an assumption to simplify the things. Okay, the total cost is constant every month, which include that's everything, yeah, including the number of sales, fixed cost, variable cost. Okay? And then the customer will pay us after T month. T is a variable. Okay, that means the first 3 months, T is, for example, 3 months. Okay? So you need to shoulder this cost without the revenue. Okay, so after T month, okay, then the customer will pay regularly for that product that we have delivered. So this is the strict assumption that we assume. Okay, based on that, we can create a dynamical system. Okay, so similar to the finance last time, we have a dynamical system with this accumulation of the cash flow. Okay, so let's call this A, and then at times K. K is the month, okay, and then R is the same revenue at month K, and then T is the total cost at month K, and let's define C as an initial capital at month 0. Okay, and because we assume the total cost is constant, okay, then we can simplify. Yeah, the revenue, okay, in the first T month, T here is given, okay, is 0. But once we pass this T value, then the revenue is just the normal BEP. So N times P. N is the number of demand, P is the price. Okay. Now the accumulation of the cash flow. Okay. So K here is month. So you can see the next month is equal to the today, this month, okay, plus the revenue minus the total cost. Okay, let's assume the initial things is 0. Okay, so because total cost is constant, so in that case, total cost is equal to K times T. Yeah? K is the number of the month. So in that case, we can, this is exactly the same as previous slide. Okay, so then we can tabulate. So remember the total cost is constant, which is the same as F plus P times N. Okay, and then the revenue in the first T month is all 0, and then after that R is just N times P. Can you see this? Okay, so in that case we get the dynamical system here, the accumulation. Okay, initially you have C, okay, and then this is the cash flow now. C minus T, right? And then the second one you have C minus 2 times T and so on until here you get C minus small t times the capital T. The capital T here is the total cost. The small t here is the time. Okay. So once they pay, then this part you can get with additional okay. So you can see here, this is exactly the same, yeah? But now you get revenue. Okay, now you get the revenue. So and you can see at the end, if you have a times T plus N, then this is the formula. Okay, so once you get this formula, okay, we can compute the BEP. Okay, R is equal to T. Okay. In this case, we can get, this is the dynamical system that we will use. Okay, from here, we can derive the actual formula, which is all in yellow. Okay, so the capital that we need is just the time times the total cost. Okay, the total cost is fixed cost plus the variable cost. And then from here, we have this formula in here in the right hand side. So from here you can use algebra to derive this formula, okay, with this n equal to 1 divided by the variable cost, the unit variable cost, okay, multiply by, now the C is the capital divided by the delay payment minus the F, yeah? F is the fixed cost. Okay, from there you can also derive this formula of the price. Okay, so I think that derivation here is important so that you know you don't get formula just for granted. So with that we can conclude. So I just put all these yellow things here again. Okay, so this is exactly the same as earlier. So this is the conclusion that we will use. This is the formula that we use. Okay. Now, based on that, now you can compute. Okay. So suppose you have the overhead cost of 2,000 per month, and you have capital of say 10,000 a month. You can handle 4-month delay. The unit cost per item is 5. The question is, what will be your minimum selling price to reach the BEP, and how much is the quantity demanded? Okay, so this is the normal BEP price and demand. Okay, but now you can simulate what will happen if you have a lower capital than this, and what will be the minimum capital. Okay, so again we can use those formula a while ago. Okay, we just plug in the values. Okay, you get 100 items, and the minimum BEP price is 25. Okay, now interestingly, of course, if your capital is actually only 6,000, okay, even for the fixed cost alone is not enough, right? Because you have 4 months, so 2,000 times 4 is already 8,000. So 6,000 is not enough, right? So then the question is, how much is the minimum capital for this? Okay, the minimum capital, okay, let's say you just sell 1 unit. The M star is 1 unit. Then you just put in to the same formula. Okay, then you will get 8,020. Wait, is there any question up to here? Yeah, this is interesting now, because now you know how much is the minimum capital, okay, that you need, okay, based on the price and demand. So a lot of things here, and now we can also include the gross margin. Okay, remember, gross margin is very important numbers that represent the probability risk transfer, yeah, from the employer to employees and so on, right? So now if we know the fixed cost and the unit variable cost and the time, okay, and the capital, then what is the relationship, okay, with the gross margin? So this is the interesting relationship that you probably want to memorize. Okay, so the capital times the gross margin is equal to the fixed cost times the delay payment, the time until the first receivable. And this formula comes from this derivation. Okay, so remember earlier we had this formula. Okay, this one is coming from the earlier derivation here. Okay, and then now we combine the two, and if you do the simple algebra here, okay, eventually you will get this formula. Okay. Okay, so I will let you practice now in this example. if you have fixed cost of 5,000 and your gross margin is 10%, okay, how much is your minimum cash flow to handle 3 months delay? Instead of making the tables like I did a while ago, right? So this is the table that I make in here. You can just use the formula. Okay. If you make this table, it takes so long. Okay. But if you just use this formula a while ago, then everything becomes much faster. Yeah. This one. So if you know gross margin and you know fixed cost and you know uh, the delay payment time, okay, how much is the capital? Then you just put in this formula and then you can get the capital. Okay, so simple as that. Look at this. This is exactly the same as the Excel one. Is there any question for here? Or you still try to grasp the idea? Or... Hmm? Okay, maybe practice will help you. Okay. Can you do this? Okay. So anyone who finish this can you present, and then probably will help your understanding. Yes, Mariam, you want to share?
Yes, bro. Let me share my screen po. So the problem is, suppose our overhead cost is $2,500 per month and it takes 3 months to collect your receivables. So at gross margin of 75%, how much is the minimum capital needed to avoid bankruptcy? So the given are, first is the overhead cost, which is $2,500.
Okay.
And the time receivables is 3 months, while the gross margin is 75%. So we will just simply use the formula for the capital, which is the overhead cost multiplied by the time over the gross margin of 75%. So the minimum capital needed to avoid the bankruptcy is $10,000.
Okay. Okay, this is interesting, Mariam. Can we continue that? What happened if you have only 7,500 as your business capital?
Okay.
And you are selling your item at $1. Okay, your C is 7.5, and then your small v, the small v, the yes, this is the unit variable cost, right? The unit variable cost is $1. Okay, those are in dollar, and the same 3 months. Okay, so yes, So, is this enough or not? Okay. If yes, what is the minimum price? And then if not enough, what is the minimum price? What is the minimum capital? Yeah, we can compare this. No? So V is given, so you know, if you know the cross margin, can you calculate the cross margin from here? This is small t. No, the cross margin is not known, so you need to compute first.
Oh, sorry, bro.
The same formula. Okay, so you have the C. You have the fixed cost is the same, 2,500. Times
Okay,
T.
bro.
Okay.
Sorry. Okay. So
G is just F times T divided by C, right? Capital C. Okay. So in that case, you get how much? 1,500 multiplied by 3 divided by 7.5. Oh, okay. So your gross margin is 100%, one. Okay. And then now you can calculate the price. From the definition of gross margin, you know, maybe you can find that if you know the gross margin and unit variable cost, can you get the price?
um, mm, okay.
Hmm? Probably in the slide earlier. So yeah,
Okay, bro.
price equal to V divided by 1 divided 1 minus G, right?
Sorry, bro.
You probably want to find the formula of gross margin. What is the definition of gross margin? Not here. So in the previous slide, G, okay, the definition of gross margin, I hope you still remember. G is equal to what? G is equal to P minus V, okay, divided by P. Right. That's equal to 1 minus V over P, isn't it?
Yes.
Right.
1 minus.
V over V over P. Correct. Okay. So in that case, yes. So in that case, if you know G and V, then you can calculate P, correct?
Yes, bro.
So P equal,
This is my calculator. Supposed to.
P equal, you can just use the algebra. So G equal 1 minus V over P. So then if you want to get the P, how do you get that? Okay, V over P is equal to 1 minus G, isn't it?
V
V per P is equal to 1 minus G, is that correct? Okay, and then so P is equal to V divided 1 minus G, is that correct?
yes, Prof.
Hmm.
E over
1 minus G. Okay, very good. So in that case, you can calculate the price. Oops.
Ay.
Yeah, okay, that's correct. Oops. It's okay. So that's correct. That's correct. Okay, so when you see the division by zero, that means your capital is actually not enough.
Okay po, Prof. Thank you.
Okay, so can you calculate the minimum capital? If you want to sell just 1 unit, how much is the minimum capital? The minimum capital, okay, is equal to the time for the 3 months times the total cost that you have, isn't it? C is equal to T times capital T, right? T, yeah, T, small t,
Ay, sorry.
capital T. Yeah. So that capital T is equal to the number of, yeah, N times small v plus F, isn't it? V. Plus F. So variable cost plus fixed cost, right? This is total cost. Yeah, that one is the, okay. So in that case, but the N, in this case, you set as 1. So in that case, because you want to sell only 1 unit, right? N equal 1. Okay, in that case, how much is the T? T equal 1 multiplied by the price, okay, multiplied by, plus, yeah, plus fixed cost. Yeah, plus fixed cost. Okay, and then this one multiplied by 3 months. Right, so that is your minimum capital that you need. See, okay. So yeah, I hope this is clear enough. I don't know.
Thank you, Prof.
Yeah, thank you, Manu. Is there any question? Is it clear or not? Go back to here. Okay, so this is what Marlene was doing a while ago. Okay, so what happened is we have 2,500 and your capital is 7.5. Okay, when you calculate, you will divide by 0. So in this case, it's not enough. Yeah? So to make it enough, your G star must be less than 1. Okay? In that case, capital must be larger than 7.5. Yeah? The minimum is just simple. N is equal to 1, you get 7,503. Okay, so at that 7,503, your gross margin is very close to 1. It is 99.96. Okay, remember, gross margin 1 is not okay. Okay, so in this case, your price will be 2,501. Very, very expensive. Remember, your buying cost is only $1. You are selling at 2.5. I don't think anyone will buy, right? But look at this. What happened if you increase your capital, okay, to 8,000? Okay, using the same formula. Now suddenly your gross margin reduce, and then your price reduce so much, no? From 2,501 now become 16. Okay. Now if you have a little bit larger capital, right? At 10,000, so your gross margin down so much, now becomes 75%. Okay, and then your price also down so much, yeah? From 16 now become 4 only. What's the meaning? That means that the larger your capital, okay, you can reduce the BEP gross margin here, and then you can also reduce your BEP price, okay, while keeping the fixed cost and the delay payment in finance. Okay, so remember when we said this 7,503, this is not something that you desire, okay? Because at this point, your price supposed to be very, very expensive, okay? So you need to increase your capital to be able to real compete with the others. So at this point, probably you will settle at 10,000, okay? So this is it is interesting to see, okay, there is actual relationship between the capital and the gross margin and the price, right? So I try to tabulate that, okay. You see here, this is the graph, okay, and at capital, the minimum, it is 7,503 that I did a while ago. The price is actually 2,501. This is here. Okay. And then when your capital is a little bit higher, say at 8,000, the price reduced so much from 2,500 to become only 16. Okay. And then at 10,000, okay, your price now become 4. But if you increase the capital a lot, okay, eventually the P will go nearer to the V here. Okay, so it doesn't really help a lot. So at certain point, the capital, okay, say up to, say, if you look at this asymptotic here, at certain points, okay, your capital does not help a lot because it will just go nearer to the unit variable cost. Is this clear or not? Okay, so this is the one that a while ago. So we can also calculate this. Yeah? Now I want you to see this. Yeah, that the larger your capital, okay, you can afford to make cheaper price. Okay? And this is why the trading distributor can afford to give you a cheaper price if you buy in bulk. Why? Because they need to be BEP, they need to sell a lot. Yeah. So I hope you can see this simple formula that explain a lot of things here. Yeah, this is the one that you supposed to make as your assignment. So if you did it, this is exactly what you get, right? So I'm just putting here as the formulas that we used a while ago. Okay, so Susi is a small trader, okay, with only 10,000 capital, okay, with fixed cost 2,500. Okay, she need 833 items per month, okay, and revenue at BEP is 33.3, so 3,300. Okay, Larry is a large trader. Okay, he need to sell a much bigger amount, okay, at lower gross margin, okay, and much lower price. Okay, and of course the revenue is also much bigger. Okay, so the small trader need only to sell at least $4 to survive, but the large trader can afford to lower the price up to 1.4, yeah, per items, okay, in the hope to sell larger volume. So this is the simple model that explain how the trading work in the real world. Okay, and interestingly, if you see here, the revenue divided by the capital is actually invariant. Yeah? It's the same as 1 divided by the delay payment T. Okay, so you want to practice one more? Okay, can you do this? So what happen if your uh, cost is actually $2 per items, and then this is your fixed cost, and you only need 1 month for the payment, but your capital is only 7.5. Okay, is this enough or not? And then if not enough, so can you find the minimum price? If it is enough, you find the minimum price. Anyone can do it? Anyone want to share your screen? Oh, who's that? Hmm? If you have any questions, so please. Give me feedback. So is this something useful for you or not? Or is this something difficult? Anyone want to share screen? Yeah, Mayan again. Yeah, go ahead.
I try to answer again, sir.
Okay, good. All right, so 2575 1. So n is 25. So the price is 3. Okay. Okay. So in this case, the minimum capital is 25. Okay, but you have 75, so more than enough,
Yes, sir.
right? Very good.
Thank you po.
Yeah,
Thank you
because the
po.
delay payment is only 1 month, so I think this is more than enough. Okay. Okay, very good. How about the others? Is there any problem that you face you want to tell? Or it's just easy? Seems like very quiet. Quiet means you understand or you don't understand. I don't understand. I don't know which one. Right. Yes, Genevieve, you want to say something?
Sir, can we have more practice?
Oh, okay.
If you
Okay, you set your own numbers in that case because I have no more numbers there. So you set your own numbers. Okay. So say you have your own problem. Say you have a certain capital or you want to know the capital.
maybe you can provide us, sir, the
Okay, so
numbers.
let's say you have a certain capital that you have in pesos. You can just put, okay, and then say you have certain delay payment for your business, okay, and then say to buy certain one product, you buy from from factory or from another store, right? That is the small v. That is the unit variable cost. Say you are selling fish, simplified fish, bangus. Okay, so how much is the price of one bangus? Say you buy in the province, okay? So how much is the price of one bangus? And then that is the small capital, the small letter V that you buy, okay? And then the fixed cost is your own food. In 1 month, of course, you need to pay for your own food. That is the capital F, fixed cost. Okay, that include your transport, your marketing, and so. Okay, so you have the fixed cost. You have your the price of one unit product. Okay, then the question is, oh, you have now when you buy the fish until you sell, there is a delay payment, isn't it? Meaning from the time that you buy until the time you can sell. Okay, say 1 month. Okay, you put in the refrigerator, that's included in the fixed cost. All right. So the question is now you want to find how much you want to sell that bangus that you buy, say 40 pesos in the province. Now you want to sell how much? Okay, and then you want to know how much is the minimum price that you want to sell so that be break even only, and then how many units that you need to sell. Okay, and then how much is your actual capital, minimum capital that you need. See, three questions. Okay, given your small letter v, time, delay payment, and your fixed cost. Okay, this is interesting. Huh? So you can also apply in transportation. Huh? So how much is your budget, the capital, Okay, how much is your overhead cost? Okay, and then how much you procure for the items. That's a unit variable cost. And then from the time that you buy until the time that you earn, that is the delay payment. Then you need to know three things. Okay, what is the minimum capital? How much do you are selling? And then what is the minimum demand? The formula is just there. So can you try? You can put any number, okay? And then we check, oh, this is enough or not enough. Uh, the, the, the formula is just there. Can you see? Simple as that. Three formulas that we have there. Anyway, the recording of this video probably will be sent to me on either Monday or Tuesday, but your midterm exam is from tomorrow, okay, until Friday. So it's up to you if you want to do it tomorrow, but the midterm exam will include this one. Go ahead.
Sir,
Yes, go. I will
sir,
stop.
can I try them, sir?
Yes, please.
So for
Okay.
this case,
Yeah.
for the V, which is the unit cost,
Okay. This is your
which
price
is
of the house, right?
assuming, yes, this is actually the price here in Iloilo for a bangus
Okay.
with a large bangus. So
Okay.
100. And then my fixed cost, which is for the food, sir, right?
Enough for 1 month?
Enough for 1 month, sir. I'm
Okay.
only one here, sir, so
Wow.
it's 4,500.
Okay. So
And for the time, which is 1 month,
1 month.
given is 1 month, and for the capital, 5,000.
Okay, let's
So
see. Okay.
if we want to get the N asterisk,
Okay.
we have to divide 1 by V multiplied by capital over T minus F. So my answer is 5.
Okay. So you need to sell 5 bangus.
5 bangus.
Okay.
And for the selling price,
Mm-hmm.
so my selling price is at 1,000.
Very expensive, 10 times.
Expensive bangus, sir.
Yes.
And for my capital, it's
Minimum. This
5,000.
is the minimum is N is 1, right?
Yes.
Wait.
No, this is 5, sir. If minimum is 1, sir, I should have a capital of 4,600.
Correct. That's correct. Now let's change that. Your capital to become 10,000 pesos. See your capital there. Oh, now you need to sell 55. Okay, instead of 1,000 pesos per bangus, now you can sell at 180.
100. So the
Ah,
higher the capital, sir, the lower you can sell
afford to
an
sell.
item.
Yes. But at the cost of meaning that the demand must be much higher also. Instead of selling one, now
Mhm.
selling 55.
Yes. So the higher the capital, the higher the selling, the number of items to be sold, and the lower the price.
Correct. Correct. So this is
Thank
the
you.
one. Look, remember, this is the one that with the star and star P star. That is the break even. Yeah, that means minimum that you need to get. Right. Minimum price. That means if you are selling at what 200, of course you get profit. But if you are selling at 181, you get no profit at all. It's just to cover your costs. The same thing, if you are selling at 181, but the number of demand is not 55, but probably 60, then you get a profit also, right? So this N star and P star are the minimum, so that you will either profit or lose. So this is not the condition that you like, but at least this will give you some clue, okay, how much you need to target yourself. Okay, I hope this is clear enough. Interesting, no? Right? Okay. Anyone have any question or comment or feedback? Go ahead. Now, yeah, this is the formula a while ago, okay, that we use. Okay, make sure that this value, the one in red, must be positive, so that you can make the number of demand positive. Yeah, yeah. Because this is must be positive, that means what? If C divided by T minus F must be positive, must be larger than 0. That means C over T must be larger than F, right? So, or C is larger than F times T, right? So that means the capital must be larger than the fixed cost times the delay payment, yeah, the time receivable. Yeah, as simple as that. Yes, Junati, you want to ask?
Sir, I have a question, sir, because I wasn't able to get it earlier. If you mentioned earlier that if your G asterisk, your gross minimum price
Gross
is
margin.
at margin is at 100%, it's not ideal. Why is it, sir? It's not ideal that.
You cannot make your gross margin 100%. Why? Because if you put your gross margin is 100%, your capital is not enough, right? That means if you put here, where is the? Oh, there, here. Can you see this line?
Yes.
Oh, there. I'll just show you a while ago. There, this one. Okay, if your G is 1, that means 100%, right? So your price will be divided by 0, right? So that means this is an indication that actually your capital is not enough. Okay, so gross margin should not be 1, because 1 minus 1 is 0. So you cannot divide by 0, right? So that means your price is infinity or approach infinity. We can just prove that easily. You can see here what happened if you sell at 1 unit and then you put here the capital is actually the minimum. Okay. In your Excel a while ago, you have the minimum, right? The minimum capital. And then you calculate the gross margin, and then you calculate the price. The price will be very, very expensive, isn't it? in your case a while ago, 1,000, isn't it? The price. So that because your gross margin is so high. Yeah, your BEP gross margin, yeah, your BEP gross margin is so high. So in this case, it's not really feasible. Okay, so if you increase your capital a little bit, you see here, okay, instead of 7,503, okay, I increase it to the capital income 8,000, suddenly become a normal. So become 16. If I increase become 10,000, suddenly the price go down, become a regular price of $4. Okay, so and this is the table that I said a while ago. See, look at this value. Okay, the one that asymptotic here. Okay, it show that look, I don't want to have the one in this side. Okay, with this very big gross margin, big gross margin. Okay, so this is the one that you don't like to happen. So make it smaller with increase of capital so that you can get the actual demand. Okay,
Thank
with
you.
that,
Thank you.
yes, yeah, thank you. So we can start to learn, okay, a business tip from BEP, right? So these are the formula of that we use. From there, we can say, look, to increase the profit, okay, very simple. We are in the same direction here. Profit is equal revenue times minus cost. That means to increase the profit, you need to increase the revenue and of course reduce the cost, right? The total cost, right? But at the same time, this R is equal, or the T here, the total cost is fixed, equal to fixed cost plus variable cost, and the variable cost is equal to the demand times the unit variable cost. In this case, you can see if you want to increase the profit, you need to increase the demand, right? The total number of items that you sell per month. Or you can also increase the price, okay? Or because this is actually a gross profit per item, P minus P, you can also increase this one, yeah? The difference between the price and the unit variable cost, right? So that is based on the formula alone, you can start to think of deduction, okay? And because we have this formula a while ago, the capital is equal to the fixed cost and the delay payment divided by the G. Here is not normal G, but this is the G star. That means the larger fixed cost, okay, and the longer delay payment, you need larger capital, right? So of course, in this case, you want to lower your fixed costs, okay? You want to lower the delay payment, okay? And at the same time, if you want to get the higher gross margin for the same price, you need to increase your gross profit per items. Okay? So if you have gross margin is actually very low, okay? For example, a while ago, in that example, a while ago, you have only 10% gross margin. Avoid delay payment as much as possible. Okay. You give them penalty, for example, if you think they want to do a delay payment. Yeah, that's the strategy. Okay. Okay, so this is the next topic. But before that, I want to ask you, is there any question for the usual deterministic PEP? The next topic, we will going to deal with stochastics. Any question? Not at all. Sure, yeah. Okay, let's deal with stochastic then. Question first. Are you familiar with normal distribution? Did you learn statistics at all?
Yes.
Yes. Okay. So, oh, one more question. Have you ever learned about linear programming? What? Okay. So no. Okay. Optimization, you did not learn at all.
No.
No. Okay. Thank you for that information. So, let's discuss the simple statistic. Okay. I will share my screen. Can you see it? Okay, so now we combine, okay, in this slide, we will combine your BEP, just the usual BEP, okay, without capital, with demand, okay, with the demand, okay. The only stochastic here is only the demand is now normally distributed. We know that the one is normally distributed. That is the assumption here. Okay. So BEP analysis is done regularly. In any business, you do it regularly. Why? Because the demand is actually fluctuated over time. Okay. This month demand is not the same as tomorrow. In fact, for example, oh, tomorrow there is an event. Okay, so then the demand is changing, right? So in that case, you need to compute again. Okay, so let's assume, okay, that demand is the only random variable, and let's assume that demand is actually normally distributed. Okay, you know, normal distribution have two parameter here. Okay, the mu and sigma. Mu is the average, sigma is the standard deviation. Okay, so now let's discuss that we want to use BEP analysis with normal distributed demand. Okay, why? Why we want to do this? Because we want to get the probability of loss and probability of profit. Okay, and we want to get the expected monetary value. Okay, based on the actual demand. Okay, okay. Let's start. So before we discuss, you know, normal distribution is a symmetrical distribution. Okay, and say you don't know anything about it. Okay, what you know is only estimate. Okay? You know the lower bound of your demand and the upper bound of your demand, and you know the average. Okay, three things that you know. Okay, the lower bound, the minimum demand, the maximum demand, and the average. Okay, and you guess that minimum bound is like how many percent probability. Okay, so remember the upper bound UB here minus the mu is exactly the same as the mu minus the lower bound. Yeah, mu is the average. Okay, why? Because normal distribution is symmetric. Okay, so to the left and to the right of the middle is the average. Okay, so now because you learn statistic already, you already know about this z value. Okay, the one that you put in the normal distribution is the standard normal distribution is actually z value, right? Okay, the value that is a standard normal. Okay, so say you have the demand n, okay, and you have the average demand mu, okay, and you have the standard deviation sigma, then you can calculate the z value. Okay. Now, if there is a probability P that the demand will be lower than the lower bound or the higher than the upper bound, then you can calculate the Z. Okay. So in that case, we can reverse this formula. We can reverse. Can you see? Okay, the sigma I put on the left hand side. Can you see this? Okay, the z I can put at denominator here. Can you see that or not? Okay, so the n here, the demand, I can put it as either lower bound or upper bound, right? So then I get this formula. Okay or not? Is there any question or you need more basic than this? Yeah, if you learn statistics, you know normal distribution, you know z value. This is the usual normal distribution value. Okay, and then what I'm doing is just simple. I just reverse the z, I put it down here, and then the sigma, I put it on the left hand side. That's it. And then the n here, I can put anything, right? So n is the demand. I can put any demand, or I can put as lower bound or upper bound, right? With certain probability p. Okay, so let's do example so that you probably with the example you will get clearer. Okay, so suppose your demand is known to be normally distributed. Okay, the most likely sales is 8,000 items per month. So what is this? The average. Most likely is the average. Okay, but it can go as low as 5,000 items per month. So what is this? The lower bound, okay, the minimum, okay, and or as high as 11,000 items per month. So this is the upper bound, okay. Let's say this is like the maximum, but the term minimum and maximum is like the most extreme. We don't use this. Instead of maximum and minimum, I'm using lower bound and upper bound. Why? Because the minimum is infinity. The maximum is also infinity. Okay, in normal distribution, the minimum is infinity, maximum is infinity. So, but this value of 5,000 and 11,000 is just the lower bound and upper bound, which about 15% chance of being lower than 5,000 or 15% chance higher than 11,000. So what is this 15,000? The P, the probability. Oh, I can use now. See, can you see this? I have the probability P. Okay, I have the lower bound. I have the average. Can I get the standard deviation? I have the lower bound. I have the average. I know the probability. Can I get the standard deviation like that? Is it clear or not? Okay, let's try. Okay, so what is the standard deviation of the demand in items per month? Okay, oh, we can just use that. Okay, the Z, if you use Excel, okay, this is the formula in Excel. Okay, P is given, right? P is 15%, so 0.15. Okay, and if you put this 1 minus P is 0.85. So the Z is now given by Excel. In the old way, you use table, okay? Now you have Excel, why you use table again? So better to use Excel, isn't it? Okay. So then all you need to do is compute. Now, the UP is 11,000, the average is 8,000, so you minus, divide by Z, you get 2,894 as your standard deviation, okay? Well, how about if I don't want this? I want to use the lower bound. Oh, you will get exactly the same, but the P is different now. P is not 1 minus P. Now you use P, okay, which is 0.15. Again, because this is symmetric, so what you will get is minus of this value. Okay, then the LP minus the mu, you get that. Oh, you get exactly the same standard deviation. What I'm doing here, knowing your middle part, your lower bound and upper bound, you can estimate the standard deviation. of the demand. Is it clear or not? Oh, clear, yeah? So now let's combine this with BEP, okay? Okay, so suppose our business, okay, have a fixed cost of F, yeah, the 36,000, okay, the unit variable cost, the small v, $4 per item, okay, selling price, the P is $10 per item, okay, and for this month, your sales is very high, 11,000. Okay, the average a while ago is already given, right? The average demand is 8,000 per item. The division is already computed a while ago, 2894.54. Okay, so then the question is, how much is our break-even point and the profit for this month? And what is the probability that you may loss? And what is the probability that you may get profit? Right. So how to compute is C, okay? So this is the usual formula for BEP. I hope you still, because we repeat so many times, I hope you remember this. Okay, N is equal F divided by P minus V, right? So we just plug in the formula, okay? The minimum is 6,000, okay? So that means any demand above 6,000, you get profit, right? So if the demand is less than or equal to 6,000, if exactly 6,000, you get no profit, you get no loss. But if less than 6,000, you get loss. Right. So now for this month, okay, your sales is 11,000, right? So revenue is the demand times the price. Price is 10. So you get 110,000. The fixed cost is already given, 36. So the variable cost, how many items? 11,000 items multiplied by the unit variable cost, right? So 44,000. The total cost, fixed cost plus variable cost. So you get 80,000. The profit is 30,000. This is already simple. I think you got this, right? Okay. And now let's compute the probability. Oh, okay. Now, if you want to compute the probability, okay, probability is always associated with the z value. Okay, so in Excel you just put this. Okay, probability is norm standard, S here is standard distribution of z, and then true here represent the cumulative probability. Okay, so first let's get the z value. Okay, to make it profit, right? That means the average demand must be larger than the break even. Okay, the demand is 8,000, the average demand. The break even is 6,000. The standard deviation is already given. So you get the z value. Okay, so if you get the z value, what you will get? The probability. Yeah. So put it into Excel. Try this in Excel. Okay, you get this value. You will get 75%. Yeah. So this is the profit probability, right? So if you want to get loss probability, how much? Again, you calculate the loss. Yeah? In this case, the BEP is 6,000, your average is 8,000, but now because it's loss, so you take the other way around. So this is become negative. Okay, so you get this value, right? Negative. And how much is that in probability? Oh, 24%. Yeah. So then you calculate the probability of loss and the probability of profit. Yeah? So how you will decide you will go to the project or not? Okay. Of course, when your probability of profit is more than probability of loss, right? Simple. Clear or not?
Clear, Prof.
Very good. Okay. So, and then from there, you can also calculate the expected monetary value of this business, right? Given the average demand of 8,000, okay, and the same, yeah, fixed cost is 36,000, variable cost, this one, the price the same. So I just continue this example, okay? Question is how much is the expected monetary value? Okay, in that case, EMV is just P minus V multiplied by the average demand, right? It is 8,000 minus your fixed cost, yeah. So in this case, you get 12,000. So this is the expected value, okay, given the average demand. So it's still profit, larger than zero. Yeah. Okay. Up to here, is there any question? No question at all. Easy, right? So if you know the minimum, yeah, or not the lower bound, maximum, which is the actually the upper bound, okay, and the average, you can get the standard deviation. Yeah, if you get the standard deviation, no, then you can calculate the z value. Okay, once you get the z value, you can calculate the probability. Yeah, from there, the computation is rather simple. Okay. Now, this is advanced optional. I will not put in the exam, but at least you know. Okay. So what happens if you have more than one product? Okay. What happens if you have more than one product? So suppose you have three products, say 1, 2, 3. Okay. So this is what you will do. Okay. You calculate the demand, you calculate the revenue. Okay. And then you calculate the gross margin for each, okay, and then that gross margin will be the one that you use as the percentage. Okay, so let me show you an example in Excel so that you will get the idea. Okay. Let me get this with this one. Okay, so this is what I'm doing in this one first, 3 products. The one in yellow are the given. Say I have 3 products, okay. This is the unit variable cost, this is the unit price, the price per unit, okay, and this is the fixed cost, right? So what happened is, I'm trying to find the formula that I gave in the slide a while ago. Okay, so first I'm trying to get the proportion of the demand. That means I compute this BEP units and the price. Okay, and then I get the average price, and then I get the proportion, which is the BEP unit divided by the total of BEP units. Okay, or I can also get the proportion of this okay, revenue, for example. And then I do iteration up to how much is this? 15. Okay, and the result is not good. Okay, it will just go to the product number 1. And then I try again another way. Probably I will just get the proportion of the revenue here. Okay, and again we try using iteration, and the result is again not that good. Yeah, see, it will the iteration will go to product number 1 always. Okay, so then I try another way. What if I use gross margin? Okay, and this is actually the correct result. Nah? So if we use gross margin, that means first you compute the gross margin for each, and Yeah, this is the gross margin for product 1, product 2, and product 3. Okay, and then from there you can calculate the total, right? So, and then you get the proportion of that, and then from there you will get the whole things. Yeah, and in fact, if we compute up to certain iterations here, I use here up to 15. Okay, the result is actually the same. Yeah. So in fact, we don't need up to 15. Yeah, you only need 2 iterations. You see, it's exactly the same already. Okay, so the point is, this is if you have 3 products or more than 1 product. Okay, what all you need to do is to get the percentage of the gross margin. Okay, so this is the, say, product 1 percentage is 67, product 2 is another 67, product 3 is 63. In that case, you get the percentage, which is this first gross margin, okay, and then the second, and then the third. So you get the proportion of that. Can you see that? Okay, from that gross margin proportion, okay, you can go back to the slide and compute based on that formula. Okay, so in the first iteration, you just compute the demand and the revenue. J here, the subscript J here represent the products. Okay, and then look at this. You have more than 1 product, but you actually have the same fixed cost, right? Okay, for all. Okay, in that case, all you need to do is to get the gross margin, and then you get the proportion of that gross margin. Okay, and from there you calculate the distributed demand. Yeah, how much is the demand for product 1? How much is the demand for product 2 at BEP? Yeah, the same thing. How much is the revenue for product 1, 2, and 3 for at BEP? Okay, and these are the formula that you can use. Okay, I hope this is the practice if you want. Okay, you have 3 products. This is the unit variable cost, and this is the unit price. Okay, and you have fixed cost of 1,000. Okay, then you start to compute. Yeah? And this is the result, the final result. So you can see that this is the demand for product 1. Okay, at BEP. Yeah, the same thing. This is the revenue of product 1, 2, and 3 at BEP. Okay. Yeah, you can practice at home later. Yeah, about this. Now, next one is nonlinear BEP. Okay. Nonlinear BEP means, sometimes a while ago the BEP usually always linear, right? Okay. But what happened if the variable cost is not linear? Okay. Variable cost is actually log linear, logarithm, for example. What is the meaning of this? At lower sales, okay, the variable cost is much higher, okay, and then at higher number of sales, the variable cost can go down, become smaller. So this is an example of model that you can use. Okay? This is another model that we can also use. Okay? My point is, if you use the usual BEP formula, it will not work. Okay, so I give you example here. What's the example? Here. Okay, so wait, here. This is the one that given, okay, in yellow. And if we use BEP based on the linear one, you will get negative. Okay? But if you use because the demand or the variable cost is actually non-linear, okay, then of course what all you need to do is to get that non-linearity in Excel. You just put it in. So this is the one that I used, okay, a while ago as the model. Okay, with this we can calculate. The fixed cost is still fixed cost. The variable cost is the one that is actually non-linear. So then everything becomes non-linear, right? The total cost is not non-linear. Okay, this is the plot. And well, the revenue is still linear. In that case, now the BEP, how much? Oh, here, the BEP is 23 point something, right? But if you use normal BEP, the linear one, you will get negative here. Okay. So it is not true, meaning the formula that we used a while ago as a linear BEP is not correct anymore because your variable cost is non-linear. Okay, so how to do that? You just change the formula of your variable cost, become logarithm instead of linear model. Is this clear? Any question here? Or you want to practice? Give me feedback so that I know what did you learn. And so this is the last part of PEP. In reality, you see, I have actually prepared for you one assignment there. I don't know if you want it or not because you have also midterm exam. So I'm preparing for a non-linear PEP, which is much complex but closer to the real world problem. Okay, say a new publisher need to pay an overhead cost of this value per month. Okay, and then if every book that published, it pay the author, say, certain amount of money, say 120, one time per book, and then additional royalty, 5% for the sales. And then the printing cost, you get, say, $3, and then the marketing cost is per title. Okay, the printing cost is per book. Okay, the marketing cost is per title. So you have two units here. One is per book, okay, per items, and then the other one is per title. So you have two type of variable cost. Okay? So, and then the book price is $10 per book, and then the demand, okay, for each book title, okay, so you can only sell at high demand up to 6 months after publication. Then demand will be half, okay, until 1 year. So from month 7, 8, 9, 10 until 12, that is only half of the demand. And then after that, there is no more book sales. Okay, this is the assumption, but at the same time, this is more closer to the realistic. Okay, and then there is also accumulation of book titles, right? Because the publisher can publish more than a number of book titles. Okay, you can start with no titles at all. And in this case, question again, PEP. Yeah, what is the minimum number of books? and how many titles do you need to produce per month in order to sell, say, if you can sell, the demand is given here, 2,000 books per title. So, and you can add any assumption if you feel it is needed. Yeah, I don't have the answer here, but this is really interesting problems. Question to you: do you want it to be required? That means I ask you to do it as an assignment, or this is not optional? Because the excuse is because you are having midterm. Give me feedback. So what do you think?
Optional, please. Optional.
Optional, okay. So, okay, no problem. So then this week, no assignment. Okay, so please prepare for your midterm. Well, okay, the material is from the beginning, including the prioritization, MCTM, ASP, okay, knapsacks, right? Brown Gibsons, and then up to financial, and then BEP, right? Okay, so and then next week we can start with decision making, decision analysis, and game theory. Okay. The material is already in Moodle in Regulator. Okay, so good luck with your exam. Start from tomorrow morning. Okay. Any question? Go. 2 attempts for the exams. You can do it any date, almost 1 week. 3 hours each attempt for the total.
Prof,
Yes.
I have a question about the one with 3 products.
The 3 products. Okay.
Can we tell if we should drop one product?
Hmm?
Can we tell in the analysis if we should, if it's more beneficial to drop one product?
Why?
Based on the profit and the revenue and the demand.
I think if you compute that, it automatically should be able to give you, right? If you compute this based on the value that you put, okay, based on the gross margin, right? So say the gross margin is very small, for example, in here is the gross margin is really close, no? But if your gross margin is actually very small, then you're supposed to be able to do that. Let's try. Let's try that in Excel. Okay, let me do it in Excel. Where is the Excel? Yeah. Okay, so let's do that in Excel. Okay, so can you see the Excel?
Yes, Prof.
Okay, so suppose I want to say the price is, instead of 3, I will put this into 1.101. See, this proportion become automatically very small, right? So, and because this become very small, then the result here, okay, it will need much higher BEP units. Okay, and this is the actual break-even point for that. Okay. And for the product 3, okay, let's play this. Okay, the product 3, can you see the difference between the price and the cost is pretty big, right?
Yes,
So in
Prof.
this case, you will see this is a PP unit is much smaller. Okay, so let's say this is also change this to 4.5. Okay. So, or make it bigger. So, for example, 7, which of course will take larger proportion of the gross margin. Okay. So in that case, you can see the PAP unit is much smaller. Okay. For almost the same revenue. If you look at the revenue, okay, all the same revenue, but the number of units is not the same. Can you see that?
Thank you, Prof.
Yeah, I hope. Do you want to play with this so that you can make on your own?
Yes, please. Yes.
Okay, so which one you don't know? This one is the same normal PEP unit, right? So fixed cost divided by P minus P. Okay, and the break-even point is just the PEP unit times the price. So you know that already. Okay, the proportion is just based on the gross margin. You know how to compute gross margin, right? So 1 minus V divided by P. And, I think who was the one who did a while ago in Excel with the formula? Okay. Mayan or Genevieve, probably. Okay. So if we calculate the gross margin here, okay, 1, 2, 3, okay, and then you can get the proportion, right? Okay, so once you get the proportion of this, you can also get the proportion of the F. Okay, you can get the proportion of the F with this one, okay, multiply by the fixed cost. Is this clear? Okay,
Yes,
so
Prof.
okay, so once you get the same thing here, so you have the proportion of gross margin. Of course, now I want to get the proportion of that proportion of the gross margin multiplied by the fixed cost. So this is the proportion of fixed cost that we use. Okay. From there, we can calculate this one. Okay. Now we have the proportion of the F. Okay. Because we know F. Okay. We already know F. And then now you have also the P and V. Then you can calculate the usual the PEP again. The only difference is instead of 1 F here, now you have the using the F proportion. Okay, that's it. So this one is just the price multiplied by that units. So exactly. And if you do this, okay, iteration, you don't need iteration 3. Actually, you only need iteration 2 because the iteration 3 is exactly the same as iteration 2. You see, all the same. Yeah, all the same. So you don't need more than 2 iterations if you use this technique. Try it, try it.
Thank you, Prof.
Okay. So yeah, the real demand and the real PP, the real world is much more complicated than this, but at least this simplified method, it is linear, is very helpful, okay, to give us understanding. Okay, remember, model is just tool, okay, tool to give us better understanding about the real world. Okay. So I hope this is useful enough. What else? Huh. Okay, we have 5 minutes before the end, so I want to give you the what is that called? Outlier detection, but probably maybe next meeting now. Yeah. That's take some time to explain. Okay, so if not, if we have no question, I will stop up to here. Yeah. So thank you very much for today. Okay.
Thank you, Prof.
Thank you, Pro.
Thank you, Pro.
Yeah.
Thank you po.
Close this.